Good morning, chemistry students. How are we doing today? Today we're going to be talking just a little bit about covalent bonding as opposed to ionic bonding. Big difference here is just taking a quick look at the electrons and how they are going to interact. So when we talked about ionic bonding, we had ions that were being formed when an atom gained or lost an electron, right? So we had an electron that was moving, or two electrons that were moving from one atom that was losing them and going to an atom that was gaining them. Well, with covalent bonding, we have two atoms that actually want to gain electrons. So notice that as we look at these two atoms of fluorine here, that they each have 7 outer electrons. And if you remember from our ionic bonding notes, we had said that in order to be stable, an atom wants to have 8 outer electrons. So what's going to happen here, right? So fluorine wants to gain an electron, and this other fluorine also wants to gain an electron. And note that both of these are neutral. So one of the key differences, as we talked about, is that we're not forming ions. So the atoms are going to join together, but they're not going to form a positive or a negative charge. They're going to stay neutrally charged. In other words, they're still going to have the same number of protons as they do electrons. So what's going to happen here? So we're going to start with our two separate atoms, and when they form a covalent bond, what happens is that they share a pair of electrons. So what's going to happen is that we have a kind of single electron sitting here, whereas all these other ones are in pairs. We also have another single electron on this fluorine, and then all the other ones are in pairs. So these two single electrons are going to get shared by each of the fluorines. So when they share those electrons between them, it essentially counts as having 8 outer electrons. So notice for this bottom fluorine, it now has 2, 4, 6, 8 around the outside, and this top fluorine, same thing, 2, 4, 6, 8. But that by sharing electrons, these two atoms are now attached to each other. So now we have what we call a molecule. Right? So we've talked a lot about molecules. We've had this idea of molecules, but what's actually holding that molecule together is kind of the important piece that we're looking for here. It's the sharing of those electrons, and that's what we call a covalent bond, is those two electrons that are being shared and actually holding those molecules together. So what we find is that as more fluorine atoms do this, we get multiple molecules. And so when we have a sample of fluorine gas, what we actually have are a whole bunch of these pairs of fluorine molecules. Now, one thing to note about a lot of fluorine molecules and a lot of other covalent substances is that they tend to be liquids or gases. And typically that's because in a lot of them, they aren't necessarily polar. Now, what we'll talk about more later when we start talking more about the food molecules is that whether they are a liquid or a gas or even sometimes a solid depends on kind of two big things. Number one is how big the molecule is, and also it depends on how polar the molecule is. So what you're going to be doing today is you're going to practice this idea, and you're going to be drawing out some examples, and you're going to use the same idea of sharing the electrons. So you're going to show how the carbon and the hydrogen are going to share their electrons. So what we're going to have, okay, sorry about that, working out some technical difficulties. So we're going to have our carbon in the center here, and notice that it gives us the electron configuration for carbon. So it's got 2 on the inner circle, in the closest to the nucleus, and then it's got 4 on the outside. So I'm just going to show those 4 on the outside, because it turns out that those 4 on the outside are the ones that are most important for bonding. And then it shows that we have 4 hydrogens that it's going to bond with. So hydrogen, notice its electron configuration has just 1 electron. So hydrogen is going to have just 1 single electron. And as I'm drawing in my hydrogens, I'm going to put those electrons right next to each other, because that's what's going to form our covalent bonds. So we see we have 4 different hydrogens. Each of those has 1 electron, and that have matched those up with the 4 outer electrons of carbon. And so we can see here, this is going to be our covalent bond, is that pair of electrons that's going to now be shared between the carbon in the middle and then each of those hydrogens. So another way that we can represent this, as you can see down here, is what's called a stick picture, or what we would call in Lewis structure. We'll talk about that. But What you'll notice there is instead of drawing out the pair of electrons and circling those as the covalent bond is that we just draw a line showing that the hydrogen is bonded to the carbon. And we know, because it's a covalent bond, that it is holding those two things together and it's representing those two pairs of electrons. So there's some more examples if you want to try those and make sure you have the right idea. Drawing out the original dot structure like we did here with the carbon, CH4, and then drawing a methane picture as well.